Check and test capacitor, relay, OLP, thermostat and fan motor of window AC. Required tools: test board, test lamp, line tester, screwdriver, cutting pliers and multimeter. Materials: air conditioner, capacitor, relay, OLP, thermostat, selector switch and fan motor.
Now we're going to talk about the start capacitor. This is a very important component in a window air conditioner. This does not connect all through. It only comes when the compressor starts. What is the purpose of this? When the compressor starts, it needs a little bit more push, a little bit more torque because of the friction of the bearings. So this start capacitor gives that additional torque. Now once this torque is given, it has to be disconnected. Here is the run capacitor. Now this run capacitor is always in the circuit, and this maintains slightly higher voltage rating so that torque is always maintained. In electrical terms, it maintains the power factor for the compressor, so it has uniform torque available.
Test capacitor by spark test method.
Prepare the test board. Connect probe A in capacitor 1 terminal. Connect probe B in another terminal. Connect the cord wire to the power source. Switch on the test board for a few seconds and switch off. Hold the plastic handle of the screwdriver and short the terminals of the capacitor. If the capacitor is satisfactory, an intense spark will occur. A weak spark will indicate a defective capacitor. Now I am going to talk about the relay. Now what is the function of this small black box relay? Basically, it is to switch on and off the capacitor. A start capacitor need not be in the circuit at all times. At the time of the start, the relay connects the start and the run winding. After the required speed of the compressor is attained, the start capacitor is disconnected. So the basic purpose of this relay is to permit the start capacitor to be fixed in the circuit, and once the compressor reaches its speed, disconnect it. That is the purpose of this relay.
Check the condition of relay.
Connect the test lamp to number 5 on the relay and S, that is the start winding, to compressor before switch to cool. Observe the light. It will give a less glow. If the compressor does not take start, check for other electrical defects. Now we'll talk about the overload protector. This overload protector is fixed on the body of the compressor, and when it senses the temperature, when the compressor gets too hot, it has got a bimetal fixed within it. This bimetal, sensing the heat, if it is too much, it opens, and when it opens, it cuts the circuit to the compressor. So the purpose of the overload, like the name, overload, it cuts out the compressor when there is too much of current or too much of heat giving on with the compressor.
Check overload protector by using 220 volts.
Take an overload protector. Take a test lamp, plug it in the test board and switch on. Touch one lead to OLP number 1 and the other to the second and third terminals. If the bulb glows, the overload protector is good. Now I am going to talk to you about the thermostat. The thermostat is one of the main components of a window air conditioner or any air conditioner. Now, what is the purpose of this thermostat? The purpose of this thermostat to regulate the temperature in the room. So as the air comes in contact with this bulb, it is cooled, and if it is below a set point, an electrical signal from the thermostat goes to the compressor and switches it off. Once the compressor is switched off, there is no cooling, so the temperature goes up again. As the temperature is being drawn over this bulb, the temperature goes higher and the signal is sent again and the compressor switches on. Of course, the main function is regulating the temperature between a particular fixed point.
Carry out test on thermostat.
Crush ice cubes and place it in an insulated container. Mix some salt to the crushed ice cubes. Insert a thermometer inside the container. Take a thermostat and check electrical contact points. If necessary, clean the contact points with fine sandpaper. Connect two wire leads to the thermostat. Connect a bulb in series with thermostat. Connect the other end wire leads with 2-pin plug and plug it in the test board and switch on. Check that the light glows when the knob of the thermostat is not in the stop position. If the light is not glowing when the knob of the thermostat is in stop position, adjust the knob to on position. Watch the reading of the thermometer. See that the bulb glows all the time. Wait until the thermostat goes to cutoff, which will be indicated by off position of the light. Quickly take the reading of the thermometer. Remove the thermal bulb from the ice cubes. Hold the thermal bulb by hand and warm it when the thermostat goes to cut in position, which will be indicated by the glowing of the bulb. Repeat the steps for 3 readings and note the temperatures carefully and record in table. The fan motor. What does this do? Like the name goes, it handles 2 fans, the condenser fan and the evaporator fan or the blower. They are fixed on either side of the motor. So now this fan motor causes both the blowers or fans to operate and move the air either over the condenser coil on one side and the evaporator coil on the other side. Now we also have the operation of a high cool and a low cool. What is this, or how does this happen? We change the setting of the motor with a different winding, increase the speed of the motor, so we have a high cool, and we want less noise and less flow, we go into a low cool.
Carry out a test on fan motor.
Prepare test cord with a 200 watts bulb in series. Plug the test cord to test board and switch on. Touch both leads. If the bulb glows, the circuit of test cord is completed. Disconnect electric supply. Keep the unit on the workbench. Plug the unit in test board and switch on the switch. On the fan switch, if it is run, the fan motor is in good condition.